Hello and welcome. In this example, we are going to solve for another series parallel combination. In this case, it says find the resistance in kiloohms between nodes A and G. So from point A to point G, this is actually kind of saying, what if we put a meter between here and we read the ohmic value between those two, right? And if we connected a positive end to point A and a negative end to point G, what would be the total resistance if we were to measure that? So we can solve for this pretty easily. We can say that if we were at point A, how do we get to point G? And we can go straight through our R8 value there. So our total resistance, RA to G here, RAG, is going to equal R8, is for our first branch that we can go through. So that's in parallel with wherever other way we can get back down to G. And so we can go through our R1 in series with our R2 in series with our R7. So note that I did not go down towards R3, R6, R5, or R4 down here because there is no reason to. Right? We're not drawing potential down to that section, so all of those are not a part of the circuit. They do not have current in them. They have no voltage potential. Right? There will be no flow through them. And that's because this side right here will be the same net positive as this other side right here, net positive. Right? So there's no potential to draw through there. So we'll ignore them. We'll say that the only ones that are actually active in the circuit right now are R1 and R2 and R3. 7. We can solve for that. We can say that the RAG value, the resistance between points A and G, is equal to this parallel series combination. So we'll plug that into our parallel equation. We see that it's 1 over 1 over. R8 is in the first one. R8 said to be 1,000 ohms. We'll put a 1 there. Add that to the 1 over the parallel combination of the series resistors here. So we're going to add R1, R2, and R7 on the bottom of this parallel combination. So R1 is 3.6 plus R2, 4.7 plus R7 down there, 2.1. So we're given a total series parallel combination here, RAG. They want it in kiloohms. We'll leave it in kiloohms. It's currently in kiloohms because all of these are in kiloohms, and so we calculated it out, even though it's a decimal point. So we got a 0.912 K ohms. That's our total resistance from this perspective. All right, let us know if you have any questions.